So why are we interested in the geologic storage of carbon dioxide and how does it impact Iowans? As of today, 3 projects are proposed that would capture carbon dioxide emitted from ethanol plants and other industrial sources, and then transport the carbon dioxide in a liquefied state via pipeline to underground geologic storage sites in North Dakota and Illinois. These pipelines could transport up to 39 million metric tons of carbon dioxide annually. Carbon capture and storage, or CCS, is the geologic storage of carbon dioxide captured from industrial sources. It is often called carbon capture and sequestration, or CO2 capture and sequestration. In this process, the carbon dioxide is captured, compressed into a liquefied state, transported to a storage location via pipeline, truck, or ship, and then injected into the subsurface for both long-term and short-term storage. In this schematic, you can see the source of the carbon dioxide produced at a refinery or electrical plant. The yellow pipeline transports the carbon dioxide to the geologic storage site in the subsurface. Carbon dioxide can be stored underground in saline formations, depleted oil and gas fields, and unminable coal seams. Of the 3 types of geologic storage mentioned, saline formations by far have the greatest potential for storage, an estimated 2,000 to 22,000 billion metric tons in North America. Saline formations are porous formations or rock in the subsurface filled with brine or salty water and span large volumes deep underground. They are thousands to hundreds of feet below formations that contain fresh water or drinking water. In selecting a storage site, the storage complex must meet several requirements. First, the formation must be at sufficient depths to avoid stratigraphic intervals containing drinking water. Second, it must be at a critical depth, at least 800 meters, for carbon dioxide to remain in a supercritical phase or liquefied phase. And a third requirement is capacity. How much carbon dioxide can the formation hold? The capacity is determined by the amount of pore space in the formation. The formation also must have sufficient permeability so that the carbon dioxide can be injected into the formation. Finally, the storage site must also have a containment mechanism. This is accomplished through trapping and sealing. A trapping mechanism includes lateral impermeability or a closing geologic structure or geometry. A sealing mechanism is a layer of rock that has low permeability, like a shale, that overlies the formation so that carbon dioxide cannot escape or migrate upward out of the storage complex. The duration of containment of carbon dioxide is estimated to be on the scale of thousands of years. Leakage out of the site can occur through faults or fractures, injection points, or through abandoned oil and gas wells. But leakage is considered unlikely at a well-regulated site. The EPA has developed specific criteria for Class 6 wells that permit storage of carbon dioxide, which involves testing and monitoring of the migration of the carbon dioxide plume over time. In general, storage of carbon dioxide is considered safe and effective for several reasons. First, there is a foundation of extensive subsurface knowledge and experience from hydrocarbon development and exploration. Second, the results of numerous worldwide pilot projects and commercial projects have led to the development of best practices and proof of concept. And finally, investment in research has led to the validation of monitoring tools and best practices. The potential for carbon storage in Iowa was investigated by the Iowa Geologic Survey as part of the RCSP effort. The evaluation of storage potential in Iowa was limited by the lack of subsurface data that is otherwise common in areas of hydrocarbon development. Further data acquisition would be needed to explore the full potential of storage in Iowa. Captured carbon dioxide can be used for other purposes besides storage. It can be used to enhance the recovery of oil from depleted oil fields and in the manufacturing of products such as fuels and building materials. Carbon capture, utilization, and storage, CCUS, is a term that reflects the multiple uses of captured carbon dioxide from industrial processes. For more information on carbon capture and storage, please refer to the other videos provided in this series. You can also use for reference the many websites that were discussed in the presentation.